Hello, India Algebra student. In this video, chapter 1.2, we're going to talk about how to actually solve a system of equation using technology, because in 1.1 we were using elementary row operation by hand and back substitution. And yes, we can solve a lot of systems of the equation that way, and also discover if a system is consistent or not consistent. But we would like to, actually solve it by calculator. The other problem that we haven't tackled in chapter 1.1 is if I have more variables that is than the number of equation, I might have infinite solutions. So it may be a consistent system, but I would have infinitely many solutions. So how do I write the answers? And what does it show if I use a calculator to solve it? So there's two terms that I want to um, talk about for a augmented matrix, equivalent of an augmented matrix. So using elementary row operation, we can convert an augmented matrix of a system into two different forms. One is called row echelon form, which is basically what we did earlier. Is the upper triangular matrix form. It's called row echelon form, usually abbreviated as REF. So row echelon form actually is show up as when you see all non-zero rows are above any rows of all zeros. So if you have any zero row like this one, so all the zeros will be at the bottom, and then the non-zero row is in the top. So that's the first things. The second thing is if you look at each row, there should be a leading non-zero entry. So it is in the column to the right of the leading entry of the row above it. So if you have any non-zero entries in the row, they need to go in steps. So yeah, if there is another one that is non-zero, so it should be on the right side of it. And also all entries in the row in the column below a leading entries are zero. So that's what we did for the upper triangular thing. We would make all the zeros here, right? We would make all the zero below we call it the pivot position. So that is called the row echelon form, basically the upper triangular thing. Then the second form is called reduced row echelon form. It is really useful because it is used to actually solve the system without back substitution. So what is the additional thing for reduced row echelon form, RREF, is it would have all the properties that we talked about, and also for anything that is above, so this is the reduced row echelon form, for the pivot position, we call them the pivot position, where the leading entries of a particular non-zero leading entry of a particular row, all there will be zero above and below. In row echelon form, you only have zero below it because it's the upper triangular, but for reduced row echelon form, you will have zero above it. Okay. Now, if it is not a non-zero entry row, then you don't have to have zero. Okay, it's like this one, or like right on this one. This is the first non-zero entry is here, so this is not a non-zero entry, so you don't have to have any zero above it. So both of these are reduced row echelon form, RREF. So which one is more important? The RREF, the reduced row echelon form, can be used to solve systems of equation. It can be used to solve infinite solution equation and also one solution equation. So that's very useful. And a lot of calculator can convert it, convert a augmented matrix into reduced row echelon form, RREF. Most calculator, or actually some calculator, can convert it into row echelon form, but row echelon form usually is understood to be done by hand, followed by back substitution. So this is not our interest, but we like to know the name of them. Two more terms in a reduced row echelon form and also the row echelon form is, we briefly talks about it actually last time, is something called a pivot position and also a pivot column. So what is a prefix position? Is a position in the matrix that corresponds to a leading 1 in the reduced row echelon form. Oh, one thing that I forgot in the reduced row echelon form is the leading entries, the non-zero leading entry in a row, it has to be 1. So if it's not 1, you just divide by whatever that shows up, so to force it into 1. Okay, so all 0 above and below, and also the prefix entry is 1. So so whenever you have a 1 in the reduced row echelon form of being the first non-zero entry in the row, that is called a prefix position. A prefix column is the column that contains the prefix position. So let's look at this matrix. This augmented matrix, it has x1, x2, x3, x4, and this is the B side. And after we reduce it to row echelon form, you can use the calculator to reduce it. I'm not going to show it, but I'll show you how to do it later. So somehow we use the calculator to change it into reduced row echelon form. You can see that this is the row echelon form. This is not the reduced row echelon form. You can see that this is the prefix position. So this is the first non-zero entry. So this is a prefix position. Anything below it is 0. This is also a prefix position. We have 3 prefix positions, so we have 3 prefix column. Okay, and we usually would identify it as like square in this book, square being the prefix position, and the column that contains the square is called the prefix column. So basically, so you can only identify it if you have changed it into RREF or REF. So either one. But if you just look at a regular augmented matrix, you can. Okay, so identify if the matrix, so these are all either row echelon form or reduced row echelon form. So identify what they are. So let's look at non-zero entry below 0. So non-zero entry below 0 and non-zero entries. Well, above this is a non-zero entry. So we have all the prefix position have 0 above and below and below. So this is reduced row echelon form. This is the non-zero entry, so we have all 0 below it. This is non-zero entry, we have things 0 above and below it. And this is also a non-zero entry above and below it. So this is our REF, right? This is just a matrix, so you don't have to worry about what equation it is doing. So this is the prefix position, all 0 below it. This prefix position above, below it, all 0. This is not, okay? This is it also. But this 0 entry is not at the bottom, so it is neither. To be a REF or RREF, all the 0 has to be below, okay? If you switch them, this would become a RREF. Let's look at this one. I have a prefix position, and this is also a prefix position because it's non-zero entry in a row. All 0 below it, but not all 0 above, and it is not 1. So this would just be a REF, right? So this is all 0 below, and so this is REF only. Look at this one. This is 1, and then this one is also non-zero, right? So REF. Oh, well, this is done. Example 2 is identify the prefix position and prefix column. So the position would be this 2. So these 2 are the prefix column. So I would use the 2, and this is the prefix position. Prefix and this one is also the prefix position. There's nothing. It is the first non-zero entries, and there's nothing below it, so it's fine. But because this is just an REF, but it would be we would have 3 prefix column. This is not okay. And what about this one? This is a prefix. This is a prefix. This is a prefix, and you can see that this is RREF. Okay, so these 3 are the prefix column. We have 3 prefix position. Now, all these REF were from a augmented matrix. You use the calculator to convert it into RREF. So I'm going to show you here. So this one, if I am to identify pivot position and pivot column, or actually I think most important thing is the pivot column. In solving equation is I have to change it into a REF form first. So just use REF, use calculator, and the one that I use is decimal. 1, 3, -2, -11, -2, -5, 3, 17. I'm writing it down. 4, 0, -1, 1. So the way we'll do it would be switch to a browser, and then I'll just Google decimals, matrix. There is another one that you can use. But this is the one that I usually use. So, and then you wanted to have a new matrix, they would say A, and they by default is 2 by 2. But what we have is a 3, so we need to get another row, and also we need to have another column, right? One more column. So at the bottom, there is a add column things that you can do. So that's what you do. So once you do that, then you enter them. 1, 3, 3, -2, -11, just enter the augmented matrix, -2, because your goal is to use it to find the solution as well as to find the perfect column, which is very useful to see your solution. Oops, 0, 5, 0, -1, -1, 1. You can use the cursor to move them around. 1, 3, -2, -11, -2, -5, 3, 17, 4, 0, -1, 1. And then you press enter. You do REF, or I think below the, let me move it around. Yeah, below here, there is a RREF in the calculator. You say RREF-A. And then the RREF will show up here. Oh, okay, doesn't show. You see how the answer would be here? Sorry, I need to move this closer so you can see. Yeah. So this is the RREF format. So it's 1, 1, 1 in the diagonal and 1, -2, 3. So I'm going to switch back to my nooks and write down the RREF format would be 1, 0, 0, 1, 1, 0, 1, 0, -2, 0, 0, 1, 3. So now when you do this, these are all elementary, the conversion is elementary row operation, so they have the same solution. So let's look at this solution. If you are to write it back as a system of equation, what would you get? x1 equal to 1, x2 equal to -2. This is x3, right? x3 equal to 3, and there you are, it's solved. So REF is very useful because it is a elementary row operation process. So this is how they do it behind the scenes. But at the end, you would have x1, x2, x3 solved without back substitution because all these are 0. And so when you write it back, this is the solution. So your solution will be 1, -2, 3. Okay. But our goal is to identify all pivot positions. So you can see that this is the pivot position, this is a pivot position because it's the first non-zero entry. And these are all this column has a pivot position. I have 3 pivot column. PIVOT column. Okay. So remember, it's a decimal matrix. So how do they actually do it? So if you were to do it by hand, or what is the process in the computer is they begin with the leftmost column, and then they basically do the lower triangle first, and then they clean up the upper triangle, the upper 0 here. So if you want to, you can read this. So you don't do them all at the same time. You do all the bottom 0 first, and then you do the upper 0. If you are to do it by hand, which I don't require you. So so in the next video, I'll do three more example on how you can use it to solve the equation, a system of equation.